Hello children, hope you have completed the homework that I have posted in the WhatsApp group. Very good. Now we'll go to today's class. The topic is today what we are going to see. This is torque on an electric dipole in a uniform electric you can say, even so to be specific, two-dimensional electric field. So this is we are going to see today. We are going to derive the expression for torque on an electric dipole in a uniform two-dimensional electric field. Okay, what is first? I think uniform electric field. How to represent by a uniform electric field? Okay, electric field lines of a uniform electric field. That I think we have not discussed. How to represent uniform electric field electric lines means it will be either two-dimensional, in which it, for example, electric field is same both in magnitude and direction, means then you can say it is uniform electric field, like that, uniform velocity, uniform acceleration, like that. Okay, therefore how to represent by electric field lines? You can represent like this: parallel equidistant, okay, lines. This is the representation of a uniform field. Okay, either this side, whatever is the case, that is the electric field. This is the electric field in this direction. If the electric field is in the vertical direction, okay, so this is the representation of, what is that? Uniform electric field. Fine. Right. Now our job is, we are going to place a dipole in a uniform electric field, and we are going to see what will happen now. Okay, right. So let me write this one. So now we are going to see when electric dipole is kept in a uniform electric field, okay, it will experience some torque. Okay, how? We are going to see. Okay, for that, let me have a uniform electric field now. See, a vertical electric field. Okay, this is a uniform electric field, right? Now I am going to keep a dipole here. Okay, how see the dipole, how I am going to keep the dipole? Okay, let me have, see, I'm going to keep a dipole such that it is inclined, dipole AB. Okay, so this is A and this is B. A means what is it? Is minus Q, and it is a dipole na, and it is plus Q, right? And what is the angle of inclination with the electric field? It is kept at an angle of, what is the inclination between, this is the electric field, this is your electric field. Okay, and what is that? And what is P here? What is the direction of P? P will be in this direction, right? P is in this direction. Minus Q to plus Q. What is P? What is P? P is the electric dipole moment. Okay, so now I am keeping it in this direction, and the angle of inclination is theta. And I think as usual it is, what is a 2A? I think you know that this is 2A. This is 2A. Everything is okay. This is a dipole length, right? Now what I am going to do here, see, I want Because I may need the space. I may need this. So let me have here is P. Okay, anyhow, we'll see. Okay, now what I want is see, when I am keeping a dipole here, it will experience, both the charges are there, no, the charges will experience some force. Here is plus Q will experience a force. You know that electric field in this direction means somewhere here is positive. Always electric field will go from positive to negative, correct? So negative side is towards the arrow mark, and so why the electric field lines they go from positive to negative. Therefore this side is positive and that side is negative, right? This is your negative, this is negative, and this is your positive, right? Therefore your plus Q here, okay, let us start from minus Q. At A minus Q is there, na? At that will experience, the charge will experience a force. What force? It will be actually attracted towards the positive side. Therefore it will experience a force, okay? In which direction? Let me have this is the force. Okay, therefore that force F, that is equal, what is the force here? What is the magnitude of the force? Direction is in this direction. Does it downward from A? It is downward. And what is it? Is F is equal to minus QE. QE is the magnitude and minus, okay, why? Because it is a charge is negative. You know that F is equal to QE. Here, what is the charge here? Minus Q, right? Like that, you come to B. Okay, charge plus Q is kept here. When plus Q is kept here, it will be what is that? Attracted towards the negative side. That is, it is in this direction. Why? Because negative, here it is negative, na? So it will experience a force in this direction. And uniform electric field means at A, at B, everywhere, magnitude, direction of the electric field, everything is the same, right? Therefore, what is the magnitude of this force? Here, F, that is equal to QE. F is equal to QE. Therefore, now only you recall your 11th standard portion. To equal here, minus QE and plus QE. Therefore, one at A, the force is the downward direction, and at B, the force is in the upward direction. So, they are equal, and magnitude wise both are same. Therefore, two equal and opposite forces which are separated by some perpendicular distance. What is the perpendicular distance? This is A. This is the force at A, and at B. What is the perpendicular distance between two forces? It will be this, right? Therefore, let you give some name to it, C. Okay. Therefore, therefore, there are two forces, equal and opposite forces, but they are separated by a perpendicular distance. Therefore, definitely they will experience a torque, a couple. Okay, they form a couple. Okay, and they form a couple, and in which direction it will rotate? Here, QE means what is that? The couple means what is that? Experience a torque. Therefore, turning effect will be there. That force will have some turning effect. Therefore, that force will give some turning effect on the dipole. Therefore, here F will be, it will be moving in this direction, B, and A will be moving in this direction. Therefore, rotates the and therefore the couple which rotates the dipole in the anti-clockwise direction. Anti-clockwise direction. Okay. Therefore, what is the function of this couple? That is this couple, that is torque. Couple. What is that? It is torque. Moment of the couple. We are going to see after the. Okay. Therefore, what is the function of the torque? The couple tends to align the dipole axis, okay, along the electric field. That is the function. Couple, it tends to align the dipole in the direction of the electric field. Okay, therefore, now what is the torque? Therefore, torque, I think you know, torque is equal to R cross F. What is R? R is the perpendicular distance between the two forces. Therefore, that is nothing but the arm of this couple, right? Therefore, that is nothing. What is R here? Perpendicular distance AC, okay, into F. Okay, therefore, what is that? Crisscross. Okay, AC. What is AC? AC here, how to find out AC? Can you find out? See, what is sine theta? This is theta. If this is theta, means this will be theta, correct? Okay, therefore, what is sine theta? Sine theta, that is equal to AC by AB, na? Okay, therefore, what is AC? Is equal to AB sine theta. That is, what is AB? 2A. Therefore, 2A sine theta. That is your AC. Correct? Therefore, you can substitute here. It is 2A sine theta into the either force. What is that? It is QE. QE. Are you following? Therefore, what is that? That is nothing but, what is 2A here? Q you take. Therefore, that is nothing but Q into 2A sine theta. Okay, that is E sine theta, correct? E sine theta. Okay, that is nothing but, what is that? Q into 2A is nothing but P. Therefore, PE sine theta. This is tau, right? Therefore, you can write, this is, you know very well that tau is a vector, right? Therefore, torque, that is nothing but P cross E. P cross E. So, this is the expression for the torque experienced by the electric dipole in a uniform electric field. But here, what is the direction of tau? How to find out? You know that it is nothing but an axial vector, right? We have seen in 11th standard. So, P and E. Therefore, how to find? Just by using, what is the right hand screw rule. Right hand screw rule. If you apply right hand screw rule, the direction of E, direction of tau will be perpendicular to the plane of the paper and outward. P to E, na? It is from P to E. Therefore, what is that? It will be perpendicular to the plane of the what is that? Paper or board and outward. Okay. So, this is the direction. Apply right hand screw rule and P cross E. Therefore, it will be perpendicular to the plane of the board and outward. P is here. This is P and this is E. Therefore, P to E. It is going like this. P to E. Okay. Therefore, this is the expression, and direction is, what is the direction? I will write perpendicular direction of tau. Okay, is perpendicular to the plane of here it is board or paper, whatever that paper, and outward. Okay, outward means here it is. Is it clear? Therefore, now special cases. Now we will see some special cases here. Special cases. Now you know what is tau. Tau, that is equal to PE sine theta. Okay. Okay. Therefore, now this is, okay, this is only magnitude, or tau, that is equal to PE sine theta. Right. Now what I want is, when theta, that is equal to 0. What in theta is equal to 0 means, okay, the dipole is kept parallel to this. I think I recall this. This is your Okay, this is the electric field. And for example, if your dipole is kept like this, it is minus q and here is plus q. Okay, like this. This is the dipole. Okay, therefore, now, okay, I think it is, it is plus, this is plus q and this is minus q. Why? I'll tell you. I'm keeping it like this. Why? Only then you can say P and E are in the same direction. What is P? P direction will be in this direction, no? Minus Q to plus Q. So P and this is your E. P and D are in the same direction. Only then you can say theta is equal to 0. Right. If that is the case, what is your tau? Tau that is equal to 0. Tau that is equal to 0. And here, very important, here the dipole is said to be in stable equilibrium. Why stable equilibrium? See, this side is negative of the electric field and here it is positive, because electric field lines goes from positive to negative side. So plus Q is attracted towards the negative side and minus Q is attracted towards the positive side. So they are very comfortable. They are very comfortable. Okay. So that is attraction. Plus Q will be attracted towards negative and minus Q will be attracted towards positive side of the electric field. Okay. Therefore, they are comfortable and they will stay there ever. Stable equilibrium. They will stay. They will be at rest. No tau, no torque. Just like that, they will stay without any problem. Okay. So this is case 1. Therefore, this is called stable equilibrium. Next one is, so this is stable equilibrium. Okay. Next one is when theta that is equal to 180 degrees. Theta 180 means kya hota? See here, this is your electric field. Okay. And this is your electric field. Okay. And this is a negative. This is positive. Everything as usual, right? Now, I am keeping the dipole like this. Here is minus Q and here is plus Q. Okay, therefore what is P direction? What is P direction? P direction, the dipole moment direction will be in this direction. Therefore here P and E are opposite. Okay, in that case theta is equal to 180. Therefore what is tau? Tau that is equal to here PE. What is tau? Tau is PE sine 180. That is equal to 0. Therefore tau here also will be equal to 0. Okay, tau that is equal to 0. Okay, there is no torque acting here, but okay, the dipole is not that stable. Why? Here is your positive side of the electric field and here is your negative side of the electric field, right? Therefore, positive towards plus Q towards positive, minus Q towards negative of the electric field means there is some instability there. They are not happy in this alignment. Okay, so this therefore this in this case you can say the dipole at any time it will be disturbed. Okay, they are not at all happy. Therefore, dipole is said to be in unstable equilibrium. Okay, so very important. It is in unstable equilibrium. Okay, now third case. What is the third case? Third case is when theta equal to 90 degrees. Therefore, you can say that tau that is equal to PE sine 90 that is equal to PE. Correct? Therefore, this is the maximum. Therefore, this is nothing but maximum Okay, value of torque. Tau max. Okay, therefore tau max, that is nothing but maximum value when it will experience maximum force when dipole and electric field are perpendicular to each other. That time it experiences maximum turning effect. Maximum torque means maximum turning effect. Is it clear? Right. Next is note. Let me go for some special cases. Even then here what happens? See, now very simple one. I am having when first one, when dipole is in uniform electric field. Okay, electric field along P. Along P. Therefore, how do you? So, this is, for example, this is your electric field. This is the direction of your electric field. Okay, now I am keeping, it is electric field, P is along, nah. Therefore, this is your minus Q and this is your plus Q. Okay, therefore P direction, what is P direction? This is your distance, okay, length, and therefore what will be the direction of P? P will be in this direction. P will be in this direction. Okay, therefore here now what is the net force? Net force on dipole. What is that? You see here, what is the force? F is equal to minus QE. Correct? In which direction? Minus QE. Here is your, what is that? It goes from positive to negative, means here is your positive of the electric field and here it is negative. Therefore, what is that? Q will be experiencing a force in this direction. That is F is equal to, therefore F will be in this direction, force. Okay, therefore, I don't want to show this one here. Already I have shown this. Okay, therefore, this is, what is that? Force direction here. But here, what is F? F will be, because negative, therefore Q, positive Q will be attracted in this direction towards the negative. Therefore, F that is equal to QE in this direction. Therefore, both the forces are equal and opposite. Correct? Therefore, QE minus QE, they will cancel. Therefore, that is equal to 0. This is equal to 0. Okay. Net force is 0. Therefore, what is net torque here? Net torque, both are aligned now. Okay, P and P, what is the angle between them? Theta. That is equal net torque, tau. Tau, that is equal to PE sine 0. Theta, that is equal to 0. Therefore, that is equal to 0. Therefore, net force is 0. Net, what is it? Torque is also 0 in this case, first case. Okay. Then, note. Then, what is a 2? Note 2. Okay. What is it? When, see, when dipole, okay, yes, in a non-uniform electric field. Non-uniform electric field. Okay. Therefore, what is that? Non-uniform. But how non-uniform means? There also there is some regularity. What is that? A, I am considering that. Okay. Field is increasing. It is non-uniform. But how? There is some regularity here. Increasing along P. Okay, field is increasing along P. Therefore, you tell me now, say, let me have some other color. See, here, it is minus Q and this is plus Q, fine. and this is the separation, right? But E here, okay, is in the direction is same, but only what is that? Direction is same, but only the value is increasing. Electric field is increasing. Therefore, it is what is increasing E. Increasing E in the direction of P. It is increasing along P means what is P here? P direction will be in this direction. Okay, therefore increasing E in this direction. Okay, as you go from, if you give AB, as you go from A to B, the field is increasing. Okay, and but the direction is along P only. Okay, therefore how do you say here? What is F here? Here in this side, because field here is less. Okay, at A field is less, at B field will be more. Therefore, what will be the force here? F is equal to Q into E. Therefore, here when you compare here, less force on minus Q. Less force on minus Q. And what is the direction? Direction will be in this direction. Okay. And at B, because E is increasing from A to B, means here, what is that? Q into, F is equal to Q into E. Now here, F is equal to minus QE, correct? Therefore, that will be in the, but it is less. But here, more force on plus Q. Okay, therefore it is F dash. Why it is not F? Because it is more. Okay, so I am representing by something else. QE. Okay, therefore you know that F dash is more than F. F dash is more than F. Therefore, what will be the net force? Therefore, net force. Okay, therefore, let me have this. It is not F1. It is F dash, and if it is F double dash, because F is F double dash and F dash, because F is the net force I have kept. Okay, therefore, what do you say here? What is the net force? Net force, therefore, net force will be in this direction only. Okay, because more force is in this direction now. Therefore, net force will be in this direction. Right? Therefore, what is your net for now? Therefore, here net force along P. Correct? Net force along P. Net force is along P. Right. The net torque. But net torque is nothing but is not going to matter. What is the net torque? Net torque here. What is the angle here? That means the angle between E. Whatever is the value of E, but angle between P and Q is 0 only. Theta, that is equal to tau. That is equal to P E sine 0. Therefore is equal to 0. Okay, so there is some net force along P, but net torque, that is equal to 0. The first case, no net force, no net torque. But the second case, there exists some net force in the direction of P. Okay, right. Then third one, B. The same. Okay, what is it? B. Field is decreasing along P. Okay, what will happen now? You see here, okay, let me have the same cos to differentiate. Here it is A, and here is B, and here is minus Q plus Q. Okay, now therefore it is decreasing E, correct? Decreasing E in this direction. Okay, therefore where will be your here decreasing? If you go from A to B, what is the field is decreasing? Therefore force on Q Let the force on minus q, let it be, what is it, f dash now? F dash is equal to minus QE. Okay, correct. But it will be more. Therefore, more force on minus Q. And in which direction? It will be in this direction. Why this side? Once again, I am telling this side is positive the electric field and this side is negative of the electric field. Therefore, it will be attractive. Now, next to 1 plus Q. Therefore, what is F double dash? F double dash, that is equal to Q into E. Right. Therefore, what is the less force? Why? Because electric field is decreasing. Okay. Therefore, less force on plus Q. Less force on plus Q. But here, your F dash is more than F double dash. F dash is more than F. Therefore, what is the net force? Therefore, net force will be in this direction. Correct? Net force direction will be from right to left. Right to left. Is it clear? Therefore, net force here, therefore you can write here, net force on dipole, yes, opposite, is opposite to P. Fine. Net force is opposite to, that is a net force. Net force is P. Why? P will be in this direction now. P kaun sa direction mein hai? Negative to positive. Therefore, but your net force will be opposite. But net force on dipole is opposite to P. But what is net torque? Net torque equal to 0. Why? Alignment, because both are parallel. P and D are 180 now. No, sorry. P and D are same only. Therefore, what is that? Net torque tau, that is equal to, say, P and E are in the same direction, I am telling. Okay. P is sine 0. That is equal to 0. Are you following? Therefore, net torque, that is equal to 0. Okay. Why? P and E are in the same direction. Okay. In all the three cases, I am telling. Therefore, is it clear? Okay. This is about, what is that? Torque experience by an electric dipole in an uniform electric field. Okay. Right. Now,